Hi everyone, I'm Lin Huiluo, a PhD student from Paderborn University in Germany. In this talk, I will introduce you our paper IDE support for cloud-based static analysis. It is a user study I conducted during my internship at AWS last year together with Martin Schiff, who is an applied scientist at AWS, Daniel Sanchez, who is a senior user researcher at Amazon Alexa, and my PhD advisor, Professor Eric Borden. First, I want to give you some background about Amazon Code Guru Reviewer. It's a cloud-based SaaS tool that performs static analysis to detect security vulnerabilities in code. To use this service, developers need to upload their code to a Git repository. Code Guru Reviewer can then clone the Git repository and analyze the code. The analysis result is in form of a list of recommendations. These recommendations are displayed in the AWS console, which is the web application of AWS. Developers can then improve their code with these recommendations. However, as you can see, this workflow poses a usability issue for developers because it takes developers outside their IDEs. Since the launch of the service, the team of Code Guru Reviewer received frequent requests from developers. They want to get the recommendations directly in their IDEs. The usual way to integrate static analysis into IDE is to develop an IDE plugin which runs the static analysis. This means the static analysis and IDE are running on the same machine. However, this approach requires the static analysis to be fast. It needs to terminate in a few seconds. You can think of lightweight static analysis tools like Findbugs or CheckStyle. This becomes very challenging when the static analysis is not so fast, like most SaaS tools that typically running in continuous integration or nightly build. So we asked the question, what if developers could have a direct line to Code Guru Reviewer running static analysis in the cloud from within the IDE? So the idea was to separate the static analysis from the IDE such that the analysis is running in the cloud while the IDE is in developer's machine. The goal of our research was to explore how such IDE support should be designed that makes developers happy. This was not straightforward as it sounds. There were some challenges we faced. For example, since the analysis is not in the same box as IDE, it means it can analyze a different version of code than the one displayed in the IDE. While the analysis is running in the cloud, developers might have made some code changes. The question is, how does analysis get those code changes? So as you can see that there was a lot of questions need to be answered at first. As next, I will introduce the approach we took to answer these questions. So our first step was to understand the expectation of developers and how such IDE support could fit into their workflows. So we interviewed 9 developers at AWS to talk about their expectations. While some developers expected to trigger the analysis manually by clicking a button in the IDE or when they build the project, the others would like the analysis to be automatically triggered. All participants told us they expected IDE support to display the result automatically once the analysis is completed in the cloud. Which part of the result should be displayed in the IDE depends on developers' primary goals. If they want to improve the overall code quality, showing entire project is desired. If they are implementing a new feature, owning findings that are in the diffs should be displayed. Developers told us they don't want the IDE support to disturb their coding flow. Most participants will search for issues and fix them once they're done with their primary task. So our next step was to build a prototype that addresses the actionable ideas from the developers. We reused the workflow of the current Code Guru Reviewer service. This figure shows you a typical workflow using our IDE prototype. First, the developer modifies code and pushes code changes to a remote Git repository. And then he clicks a button in the IDE to request the code glue reviewer to run a new scan on the Git repository. Code glue reviewer then receives this request and clones the GitHub repository. And then it analyzes the cloned repository and generates recommendations in the cloud. The IDE prototype then automatically fetches recommendations once the analysis is finished in the cloud. Here you see a few screenshots of our prototype. On the left, it shows an interface with a few buttons user can click on to send a request to the service. The prototype also takes local code changes and suggests the user to upload them before a rescan in a pop-up window as the second screenshot shows. Recommendations are displayed in a problem list as the third screenshot shows. Once we had the prototype, the next step was to test how well this prototype works. We conducted a usability test with 32 developers at AWS. We wanted to test whether our IDE solution was an improvement over the existing web solution. The developers were asked to test both the IDE prototype and the web app in 2 different sessions. In each session, we asked them to fix issues found by code glue reviewer in a prepared project with either the IDE prototype or the web app. During the usability test, developers tended to run the analysis much more often in the IDE than in the web app. As the bar chart shows, in the IDE, they run the analysis 3 times more often than in the web app. As a participant told us, the scene in the AWS console felt like integration test. Having it in the IDE was like unity test. This captures exactly the different perceptions on the workflow developers had when testing different interfaces. They wanted to validate their fixes more often in the IDE. Although developers tended to scan code more often in the IDE, they didn't necessarily fix more issues. The number of fixed issues are the same in both conditions. However, when they fix the issues, they fix them more quickly. As the figure shows, there is a promising time reduction in the IDE condition among most groups. From the after-session interviews, we learned that there were many things we did right with the IDE prototype, such as how the warnings appear in the IDE. However, some developers didn't expect they would need to commit and push code. They think these are dirty commits or they don't use feature branch at all. The others missed indication of the analysis progress. For example, a participant said that he would like to see a progress bar in the IDE. Although the IDE prototype actually showed pop-up notifications about the progress, it turns out that those pop-ups were actually less effective in teaching developers of how the prototype worked in general. If the analysis was not returning result immediately and developers' activities in the IDE were not blocked, the display of old findings and this unpredictable waiting time are basically deal breakers. Developers complain that old findings and the current code are out of sync. This indicates developers need clear visual cues to understand when the analysis is running and if findings are outdated. Nevertheless, many developers told us they would like actually to use the IDE prototype if the prototype provides a better indication of the workflow, because they would rather see the issues directly in the IDE than switching back and forth between the IDE and the web browser. From the insights I introduced, I hope now you got a sense of what needs to be implemented for supporting cloud-based analysis in the IDE. Please find more insights in our paper. Thank you for listening.